Hello students, now we'll take another example in second normal form 2NF, and now we'll consider these two or this relation named bank loans with the following attributes: bank name, assets, headquarter, loan number, customer name, and the amount. So I want to find whether this relation is in 2NF or not. The primary key chosen here is the bank name with the loan number. Okay, so in order to find whether this relation is in 2NF, first of all it must be in 1NF. Okay, let's now find whether this relation is in 1NF. For a relation to be in 1NF, all the attributes must be single atomic attributes, or must take single atomic values. And as we see here, all the attributes are single and atomic. No one of these attributes is a composite attribute. Now, this relation becomes in 1NF. Now I want to see whether it is in 2NF. There is more condition that should be achieved in order for this relation to be in 2NF. All non-prime attributes must fully depend on the primary key or any candidate key. If we found a non-prime attribute that depends partially on a part of the primary key, then this relation is not in 2NF. Let's see the functional dependencies given here. We have the FD1 tell us that bank name derives the assets and headquarter. This means that assets and headquarter depends on the bank name, which is a part of the primary key, which is the bank name and loan number. Then this is a partial dependency, and this relation is not in 2NF. In order to make it in 2NF, we need to decompose this three attributes into a separate one, and we do that here, and we make a new relation called banks with the bank name as the primary key and assets and headquarter as second and third attribute. Now we move to the second functional dependency that tell us that bank name and loan number determines the customer name and the amount. This means that the customer name and amount depends fully on the primary key, which is the bank name and loan number, and not partial. So we have no problem with FD2, but we have a problem with FD1, and we solve that problem by separating all these attributes into a single relation or a separate relation called banks. And the bank loans relation, we rename it to be the loans. So the remaining attributes will go here, and only these three attributes will go to the bank's relation. Now we need to ask ourselves whether 2NF is good enough for our relation or our database design or not. Actually, 2NF is not good, because 2NF doesn't solve for me the redundancy problems caused by other functional dependency. So a relation schema in 2NF can still have serious redundancy problems, as well as insertion and deletion anomalies. In order to convey this problem, we need to look at this example here. We have the relation called parts with the following columns: part number. Each part has a part number, which is the primary key, the name of this part, its location, its unit price, and the manufacturer ID, manufacturer name, and the manufacturer address. Actually, if we look, we see that the manufacturer ID, manufacturer name, and manufacturer address are redundant here. We can only put the manufacturer ID in a company with the parts relation only, and separate these three attributes into a separate one, because these are related to another entity called the manufacturer. So manufacturer name and manufacturer address here are redundant, and we need to only put the manufacturer ID in order to make this design a good design. So it's obvious that parts is into an F. Although this relation, or although the parts relation is into an F, there may be another redundancy caused by this functional dependency here, which tell us that manufacturer ID determines the manufacturer name and the manufacturer address. So we have manufacturer name and manufacturer address depends on the manufacturer ID. 2NF has no problem with this functional dependency, because 2NF is only considered that non-prime attributes like manufacturer name and manufacturer address should fully depend on the part number or the primary key, and this is true, but it doesn't tell us anything about if a non-prime attribute depends on another non-prime attribute like the manufacturer ID here. So to solve this redundancy problem, we need to another rule called 3NF that solves this problem. So redundancy and various anomalies are introduced by this functional dependency, and in order to solve this problem, we need to think, or we need to apply 3NF rule. Okay. Okay, here we have another example. If we have the employee department relation with the following attributes: the SSN, employee name, birth date of this employee, address, department number, department name, and the department manager SSN. Because we have, although this relation is in 2NF, but there may be redundancy data or redundancy problems introduced by the following functional dependency: the department number determines the department name and the department manager SSN. Also, here we can separate all these attributes into a single relation, and get rid of the redundancy and various anomalies that are introduced by this functional dependency. So employee department is in 2NF, but it also may have redundancy problems. Why this relation is in 2NF? Because it is in 1NF, and non-prime attributes depends fully on the primary key. Okay, and in the next video, we'll take the rule third normal form. So stay tuned and goodbye.